This is the Unit 7 test, and picking up with question number 8 here. It says in a right triangle, uh, one of the acute angles has a measure of pi over 6 radians. If the side opposite of this angle is of length 4, what is the exact measure of the other leg? So they're talking about some sort of triangle, a right triangle, of course. And so I'm identifying the right angle. And of course, when you draw a right triangle, you also have two other angles, which would be acute angles. And this is saying one of the acute angles has a measure of pi over 6. And of course, if you want to convert that to degrees, that ends up being 30 degrees. Okay. If the side opposite this angle is of length 4, so they're telling me this leg over here is a 4. All right. Then what is the exact measure of the other leg? Now the other leg would be this side right here, the side that produces the right angle with the side that's been identified as a 4. The other side of the triangle is not a leg. Remember, this would be the hypotenuse, and so they're saying what's the length of the other leg? Well, using a little bit of right triangle trigonometry here, at least one way to do it, we have the opposite leg, and we're looking for the adjacent leg. And so that would indicate that we're going to be doing a tangent of 30 degrees. And of course, the ratio for the tangent is the opposite leg, which is 4, over the adjacent leg, which is the unknown. All right. Now from here, if you want to do the tangent of 30 degrees, that should be something that you can either uh, do by reference triangle or do by some sort of chart, either a table or using the unit circle approach. The tangent of 30 degrees is 1 over the square root of 3. Okay. Or perhaps you know the tangent of 30 degrees. You have that committed to memory as square root of 3 over 3, whichever value you would want to use. Um, Now again, notice if you rationalize the denominator of 1 over the square root of 3, that you get square root of 3 over a 3 in the denominator. So those two values, square root of 3 over 3 and 1 over the square root of 3, do identify the same number. From here, either approach, we would cross multiply, and 1 times x is of course x, and 4 times the square root of 3 is 4 square root of 3. And there's all they're looking for. That's our exact value, right? Because they asked for an exact measure. So the exact measure of the adjacent leg would be 4 times the square root of 3. Okay. And so that's question number 8. Question number 9 identifies a factoring exercise. And so I'll clean this up and slide up the page just a little bit. And we can look at question number 9. Factor completely, and this 2x cubed minus 3x squared minus 18x plus 27. And this lends itself to what we called factoring by grouping. It was in Unit 1. And if you look at the expression pairwise, that is, if you look at the first two quantities, you can see that they both share x's. And the rule when factoring is typically to factor out the lowest power you see. So we'll divide out an x squared. And that's going to leave me, when 2x cubed is divided by x squared, that's going to leave me with a 2x. And when minus 3x squared is divided by x squared, that's going to leave me with a minus 3. And now as I look at the second pair, the third term and fourth term, first of all, I notice the third term is a negative 8x, so I'm going to factor out a negative. And 18x and 27, Greatest common factor there would be a 9. So I divide each term by negative 9. And negative 18x divided by negative 9 is going to be 2x. And 27 divided by negative 9 is going to be negative 3. And there you see the common factor, the 2x minus 3, between both pairs. And so we continue by dividing out that 2x minus 3 from both of those expressions. Dividing the 2x minus 3 from the x squared times 2x minus 3 is going to leave you with an x squared. And dividing the 2x minus 3 from the minus 9 times 2x minus 3 leaves us with a minus 9. Now, that is factored, certainly, but it is not factored completely because you should identify the x squared minus 9 as a difference of squares. And so it can be factored into the conjugate pair in some order of x plus 3 times x minus 3. So there's your three algebraically prime factors in order. And you could, of course, have them in a different order, but that would be your answer to question number 9. All right. Question 10, after we clean up question 9, is an exponent question. To simplify and eliminate any negative exponents. And these, because of the formatting, which is something we'd like to clear up for the next iteration of this program, you're looking at x to the 2/5 power, and then that is being raised to the minus 3/4 power, just so that's clear what's going on there. And of course, raising a power to a power, I'll execute that first, and we get minus 6/20. Because when you raise a power to a power, you multiply the exponents. And to multiply fractions, you multiply numerators and multiply denominators. Now, continuing, I'll reduce this thing first. And they're both even. And so this would be x to the negative 3/10. All right. And then, of course, we have to remove the negative exponent. And to remove the negative exponent, we'll use the 1 over rule. That is, you can change the sign of the exponent by moving a multiplied term to the denominator, leaving the placeholder 1 in the numerator. And so we've got 1 over x to the 3/10 power, which would have been the final answer we were looking for. All right. So that is question number 10. And we'll pick up with 11 as soon as we clean up number 10. So cleaning that up and now sliding up the page just a little bit more. Evaluating negative 27/8 to the 2/3 power. First of all, it's important to understand what this fractional exponent means. This fractional exponent, the numerator of the exponent is the power, and the denominator of the exponent is the root. So in essence, what this is saying, one way to write it, would be it's asking for the cube root of 27/8, of actually negative 27/8. And then they want to take that result and square it. Now, it could be written the other way. It could be written as negative 27/8 squared and then do the cube root. But typically, in terms of evaluating, in terms of simplifying, you want to do the root first if you can, because that's going to make the number smaller to work with. Now, cube root of 27 or cube root of 8, okay, first of all, you can have negative odd roots. Cube root, fifth root. It's okay to have a negative under the radical. It doesn't become imaginary as it does when you're doing, say, square roots or even roots. So in terms of cube root, of 8, that should be pretty quickly identified as 2, because 2 times 2 times 2 is the 8. And then the cube root of negative 27 would be negative 3. All right, so the expression under the radical, right, cube root of 8 becomes 2, and cube root of negative 27 becomes negative 3. Now, if we carry out this squaring, that means we're doing negative 3 halves times negative 3 halves. And so the final answer should have been 9 halves. Probably could have written 4 and 5/10, 4.5 as an answer. That would have also received full credit. Um, Number 12, I guess we have space for. This is a compound fraction, 1 over n plus 2. This came from the second unit of the refresher program. Um, Minus 1 over n, okay, over 1 over n. Now, you might have seen a few different techniques working with these in high school. Um, what we tended to use was looking at all the denominators and multiplying major numerator and major denominator by all denominators you see. Now, in this case, we have a denominator of n, a denominator of n plus 2, and a denominator of n. So we multiply by n times n plus 2 over n times n plus 2. So as a process, we're going to basically clear the denominators. We're going to clear the fraction out of the numerator and out of the denominator by multiplying by all denominators we see. Now we do that, of course, we're multiplying by the same thing divided by itself, something divided by itself, and so we're multiplying by a form of 1, so we're not going to be changing the value of the fraction. Now, in the denominator, when you do this multiplication, we'll have cancellation on the n. And so in our denominator, all we end up with is 1 times n plus 2. So your compound denominator becomes just an n plus 2. This expression right here has now become just an n plus 2. And in the numerator, of course, we have a binomial numerator. We're going to be using the distributive property as we do this. So the n times n plus 2 will get multiplied times the 1 over n plus 2. And when you do that multiplication, of course, you'll have an n plus 2 cancel. And so the n will be the only result there. And then when the n times n plus 2 is multiplied times negative 1 over n, you'll get an n cancellation, right? This n will cancel with that. But you'll be left with a quantity n plus 2 times that negative 1. So I'm just going to write it out like that. Make sure you grasp that part. The people we've looked at, who are making an error on this question, we've identified that almost always the error is occurring right there. That negative times the n plus 2, that negative is going to have to be distributed at some point. And so the n's will cancel. So then you're left with negative 1 times n plus 2. And I'm just writing it out that way, right? Negative 1 times n plus 2, which gives me n minus n plus 2 over n plus 2. Well, the n minus n zeroes out, and so our final answer on that one should have been 2 over n plus 2. Is what we were looking for there. All right. Clean up and do the final question of not only this unit test, but of the refresher program. And so there we are. Get rid of that. Get back to our writing implement here. It says in a certain right triangle. Okay. So there's my right triangle, composed of 2 legs and a hypotenuse. The hypotenuse is of length 3. So 3 goes there. Okay. And 1 leg is of length 2. It doesn't really matter which leg I identify as being of length 2. I'll make that one be of length 2. Okay. What is the exact value of the tangent of the acute angle adjacent to the leg of length 2? What is the exact value of the tangent of the acute angle adjacent, that means touching, right, next to the leg of length 2? So this angle right in here, that angle, I'll label it A, that's what they want the tangent of. They want the tangent of A. All right. What is the exact value of the tangent? So they don't want to know what the angle is. They want to know what the tangent of the angle is. Well, of course, tangent is the ratio of the opposite leg to the adjacent leg. All right. We know the adjacent leg. We know our denominator is a 2, but we're missing the opposite leg. Well, of course, we can find the measure of that opposite leg by doing a Pythagorean theorem. Right? Pythagorean theorem says leg squared plus leg square equals hypotenuse squared. We know the hypotenuse is a 3, and when we square that, we get 9. We know that one leg, it doesn't matter which, is of length 2, and the other leg is what we'd like to find. Give that an x. So we've got 4 plus x squared equals 9. So x squared is 5. Bring the 4 to the other side and use the additive inverse. And so x, since we're in the geometry realm here, is square root of 5. We reject the concept of it being a negative value. Okay. So this thing that I had labeled as a question mark right here, I can now remove the question mark and replace it by a square root of 5. And so now I know that opposite leg is square root of 5. And so the exact value of the tangent of angle A is square root of 5 divided by 2. All right. So if there were any questions on any of these, if you need more detail or more explanation, please don't hesitate to get back to us. We hope you've enjoyed and found use and benefit in this refresher, and we wish you good luck in the fall semester.